Hi everybody, want to make a quick video going over a patrolling enemy. This enemy is going to start moving as soon as we show up on the screen. It will also turn when it sees a wall, and then we'll create a potential smart mechanic that checks for ledges and make sure it doesn't walk off. So let's get started. Here is a really quick demo of the game in action. Basically, right now, the player does not see either of the two enemies, but once the player does, they start moving at them. And this one does not have edge detection, but it does look for walls. So once it sees something, it moves to the side. And the other one, when it sees an edge, it turns around. And if I hit one, I do die. If I shoot it with a gun, then it dies. But let's get into the script. I'm going to go ahead and create a new mono behavior script, which I'm going to call patrolling enemy. And once this loads up, I will start off, of course, with my instance variables. And I have a few that I'm just going to kind of jump into right away. I already know exactly what I want to write for it, but I'm going to add. Actually, what I'm going to do is something that we don't do a lot in intro, but I do find it a little bit helpful for management and organization. I'm going to add a header. And it doesn't really do much. It just adds a title in the inspector window. And honestly, isn't necessary at all, but I do feel like it organizes things a little bit better. And then from there, I know for movement, I'm going to want a couple of serialized fields. One of them is going to be my move speed. And I'm going to set it to a moderately slow value starting out. But since it's serialized, we can of course change it. And then I'm going to add a Boolean. And this one's going to be called turn at ledges. I'll default it to false, but the idea is this is for our smart enemy that actually turns when they seize the edge. If it's false, we're going to program it so that they just walk off the edge, kind of like a lemming. And then I'm going to add a couple of non-serialized fields, one of which is going to be a Boolean called isMoving. And I'm going to default that to false. It actually does default from the get-go, but we want this to turn on as soon as we show up in the screen. And I'm going to add another float, which is going to be called my facing direction. Actually, that could be an int. But it's just going to be +1 or -1. We'll use -1 to walk left. 1 will go right. And next, this is that header organization. Again, not necessary, but it does look nice inside of the inspector. This one is going to be called wall detection. And I'm going to have two serialized fields that I'm going to need for wall detection, one of which is going to be a float, which I'll call wall check distance. I'll set it to 1 just to start. How far we check from the player, I should say from the enemy to the wall. And we're going to use a raycast which means that we're going to want to use a layer mask because the ray cast will hit our enemy if we don't. And we're just going to use a layer mask to ignore it. And then the final one is going to be the edge detection. And I'm going to make one final header for that. And inside of it, I'm going to essentially have these exact same variables again, one of which I'm going to call ledge check distance. The other one is going to be important. We're going to want our raycast to not be in the center of our enemy. We want it to be slightly offset, so that they turn before they actually reach the ledge. So I'm going to call this one ledge check X offset. And I'm going to start it at something small, something less than 1. How about 0.3F? Excellent. All right, and then the only thing we still need to do is for our movement, we're going to want to use rigid body physics. It's really helpful for collisions. Actually, a rigid body 2D is what we want. It's, I think, generally better than using the transform because the transform will actually go through walls. A rigid body will actually check whether or not it's colliding with something. So we're going to do all our movement with the rigid body. And then on start, all I'm going to do is get the rigid body. And this one may seem a bit redundant, but I'm going to do it anyway. I'm going to make sure this Boolean is false. And then I do need to get the rigid body. So RB equals get component, rigid body 2D. And this will give an error if the rigid body 2D is not connected. All right, excellent. Now, one of the first things I'm going to do is a little line of code. I'm actually going to do this before the fixed update. The order doesn't really matter that much, but this is a very, very helpful method. It's private void on became visible. And what this means is as soon as any camera sees an image sprite renderer, so as soon as that happens, that's when I want is moving to become true. So basically, we won't start moving until a camera sees us. Perfect. Now the actual movement. I'm going to put that inside of the fixed update. Remember, use fixed update So it will trigger at exactly 50 FPS, unless you override it, which you can do, but it's going to be fixed regardless. So we want to use the fix update for a bunch of reasons. One is for the movement to be consistent, but the other one is so that the collision time is consistent. And I'm just going to start off with is moving is false. Just so you know, a better way of writing this would be to use the apostrophe. That means the exact same thing, but for students and readability, I write it this way. I usually won't write it that way for myself, but I do for students. And so if is moving is false, I'm going to do two things. First thing, I'm going to force the linear velocity of that rigid body to be 0. Now, gravity will still fight this, but as long as I have it above like a ground, this really shouldn't be an issue. And then I'm just going to write return. And what that means is break out of the fixed update. And this will only happen if is moving is false. So if it isn't false, then all the rest of this will happen. Maybe for readability, I'll write an else, even though that's totally unnecessary. It just helps say, like, if we are moving, then do this stuff. First thing I'm going to do is I'm actually going to write all of this script in one go. Typically, I would check as I go, but to help you guys out, I'm going to write it all at once. All right, from here, I'm going to add a new method, which I'm going to call check for walls. And the idea of check for walls is if it runs into or the ray hits a wall, it's going to turn and go the opposite direction. So in order to do that, I'm going to do a couple things. First one is I'm going to write a raycast hit 2D. I'll call it hit. It's just kind of a common name. And I'm going to use 2D physics, raycast. And it's looking for, well, you'll see the overload, but it's looking for an origin. I want this to happen in the middle of this object, so transform position. And then the direction, I want it to be the facing direction. And all right, this is a vector 2, let's see. This might be okay. Here. Let me write it as a vector 2. New vector 2, facing direction, and 0f, because I'm not looking up or down. And then the distance, that is going to be the wall check distance. And last but not least, the layer mask I'm looking for is the ground layer. This line will return really whatever the raycast hits. And ignore anything that is not a ground layer. So the raycast will ignore my player, which should not be on the ground layer. And then next, I want to say if the collider.hit, I'm sorry, hit.collider is not null, meaning if the collider hits something, Then I'm going to want it to turn around. So I'll just write facing direction equals -1 times the current facing direction. So if it were negative, it becomes positive. And then I also want to flip the image. An easy way to do that would be write transform.localScale equals a new vector2, and it will be the -1 times the current local scale in the x, and then keep the local scale in the y the same. So I'm only multiplying local scale x by -1 to flip the image. All right, that's about it for checking walls. So inside of my fixed update, if we are moving, the first thing I'm going to do is I'm going to check for walls. So if there is, it will change directions. And then to change the direction, or actually to make it go in whatever direction it should be going, all I'm going to do is write RB dot, I'm going to keep it really easy. The only linear velocity I'm going to change is my x. I'll keep y whatever it was. So linear velocity x, if you're using the newest version of Unity. If you're using an older version, it might just be linear velocity, and you'll have to create a new vector2. But the latest version does isolate the x, which is pretty nice. RB.linear velocity x equals the facing direction times the move speed. And that will make it go in whatever direction at the move speed. All right. Now, a big issue that I see right away is the fact that this raycast right here, I am assuming the wall check distance is whatever I set it to, 1. However, I don't know for sure, and there isn't a very good way for me to check on the inspector unless I do this next part, which is add a gizmo so I can see exactly where that raycast is going to hit. So private void on draw gizmos. I'm going to give the gizmo a color to start off with. Yellow seems fine. And then I'm going to draw a ray. And drawing that ray, I'm going to keep it pretty simple. The starting position is going to be the middle of the enemy, which is actually where I'm starting anyway. And then the direction is going to be a new vector2. And it is the facing direction times the wall check distance in the x, and then 0f in the y. And I actually have one more collision that I want to check for. I want to check if the enemy is hitting another enemy. An easy way to do that, I'm not going to use the raycast because since I'm tagged enemy, it's going to hit my own collider, which could be a big problem. So I'm going to write private void on collision enter 2D. and if the collision game object compare tag is enemy. Meaning if I hit an enemy, then just do these things. I think I'm just going to copy and paste it. Change the direction and flip the image. If you don't have the enemy tag at all, this will throw an error and you won't be able to compile your final game. So make sure that you do have that tag available. All right, this is about everything for us to test as a Goomba. The only thing we're missing is the ledge detection. So I would love to test it right now, but for the sake of time, I think I'm gonna go ahead and add that ledge detection this very moment. So, checking for ledges. We're going to go ahead and add a new method, similar to the check for walls, but this one will be check for ledges. So, private void check for ledges. And very similar, I'm going to use a raycast. However, this one's going to be just a little bit different because I want the X offset to be not in the center of my enemy. So first thing I'll do is I will add a vector 2. I might call this starting location. Starting ray position. Seems like a fine name. This will be a new vector 2, and it's going to be at my current X position plus, and this is important, the facing direction, because I want it to either be here or here. So plus the facing direction times the, what I name it, ledge check X offset. So that is going to be my X value, and my Y value I'm going to keep as transform.position.y. So that one does not change. I'll put the comment for that above. And then let's create that raycast hit. It's going to be a lot like this one right here, but I'm just going to have a different starting position. Actually, other than that, there will be no difference. So raycast hit 2D, call it a hit. And this is going to be a, well, physics 2D raycast, starting at the starting position. Starting ray position is what I called it. And the direction is going to be down. So I'm just going to write it like this, vector2.down. The distance is going to be the ledge check distance. And the layer is the ground layer. Okay. Yep, that should work. Excellent. Now, this is going to be really similar too. The only difference is going to be if the hit collider is known. And what that means is if the ray isn't hitting anything. Meaning no ground. If that's the case, then I'm just going to copy and paste this again. If that is the case, then switch the direction and flip the image. And similar to the check for walls, I'm going to have a gizmo for this one. And this gizmo, this is kind of fun logic, but like I want this gizmo to only be on if, what's it called? Turn at ledges is true. So if turn at ledges is true, then, let's see. Oh, I actually kind of need this starting point again. So I'm going to copy and paste that. Starting point. And I'm going to make this gizmo a different color. How about blue? And then I'm going to draw a line or ray from the starting position, just going down. So gizmos.draw array. From the starting position to new vector 2. No more offset or no to the left, so 0, F, only down, and down a distance of ledge check distance. And I actually want that to be down. Let's see. I want it to be down, so -1 times. You know what? I got a better way of writing it. Vector 2 dot down times ledge check distance. All right. Final thing. Right now, the check for ledges is not being called. So all I need to do is call that inside my fixed update. So right now I'm checking for the walls, and I only want to check for ledges if, what do I call it, turn at ledges is true. Check for ledge and turn. All right, excellent. That is everything that we need for our code. Now we're going to have to do a little bit of setup, but we can finally test this and everything should work out. All right, I'm back in my game, and I currently have 2 enemy objects that I want to run at me. Now, important little things about these. Right now, my first dinosaur, I have a rigid body 2D connected to it, which is necessary for this to work because I'm using the rigid body physics. And the body type does have to be dynamic. I kept gravity on. And this is an important part too. So I decided to put a animator on it so that it just runs like a general animation, and a sprite renderer. But in order for it to actually see me, it needs to see a sprite. So what I end up doing was I put the Dino visual on here, and this is kind of a hacky way of doing it, but it does work. I put an empty sprite renderer on the same area that I'm going to put the script. That way I know it's actually going to see something. I also have a capsule collider on there so that it can come in contact with the ground and collide with other dinosaurs. And that is about it. So let me go ahead and add the script. We called it, what did we call it? Patrolling enemy. Oops. So, okay. Here's a dinosaur. Going to drag patrolling enemy onto it. This right here is the header. So as I mentioned, it's not necessary, but it does help organize just a little bit, especially if somebody's trying to use this script. But all right, the move speed at 3 seems good. I'm really not worried about turning at ledges for this one down here, but if I were, I could turn it on and you notice this blue raycast, which is in a pretty decent position too. The ground layer is definitely going to be important so that it actually looks for ground with this one. And the ground layer is a layer that I made previously called ground. That's this whole tile collider. The entire thing is labeled ground, but I make sure to use that. So ground layer does need to be set to ground, and this also does need to be set to ground. Outside of that, I think that this one is ready to move. Now, this one right here, I'm going to do the exact same thing. I'm going to drag that patrolling enemy script onto it. And this one, I do want to turn at edges. So in order to make it turn at edges, I need to turn that on. So, yep, there is the script, there's the check. I also do want to check for the ground layer. Otherwise, it will ignore everything and just try to keep like turning, which I definitely do not want. And this should be set. Let me go ahead and press play. And when I first start, they're going to be out of my range, so they're not moving yet. But when I get into range of one, it's going to walk toward me, which is good. And when it hits that edge, it's going to turn. This one is turning at the ledges, which is nice. And one thing I notice is I think it's turning a little bit prematurely. Let's see if it actually gets me. So, all right, since it's turning a little prematurely, I'm just going to do this. The wall detection distance is 1. Let me shrink it. Oh, that's the ledge check distance, my bad. The wall check distance, 0.8. I can maybe even go down a little bit, but that seems much better. It's still looking for the ground. And how about this too? This one currently turns at ledges, but how about I just turn that off? So no longer turns at ledges. That means it should walk right off the edge. All right, let's give this a run. This one should get closer to the edge before it turns. And when it hits the other enemy, it will turn as well. I think I'm just going to move it forward a little bit. That way I get like a better idea of the collision. And it might start as soon as I start, but that's totally okay. Okay, so yep, that one's moving. And so is this one. Excellent. And I notice that when they bump each other, they change directions. Awesome. Perfect. That's exactly what I wanted. Well, I hope you found this video informative and helpful. Don't forget to like and subscribe. Have a great rest of your day.